All right. Today we'll start the chapter 5 coursework. And this first part, we have to first talk about composite functions. A composite function is a function within a function. That's a composite function. So it's a function. We have function f, and inside there, instead of x, we have another function of x. The way we write that is, we'll read that as f of g, the function f of the function g of the variable x. And we call that the fog method. And this is how we write a function of a function. So it's a function of f of g of x. So how these orders go is not that important, because whatever comes first is the outer function. So this one's the g function. Inside there is the fg of f of x. So we have f of x. And then we can also have the foff, which means f of x. And then we have the gog. So it's g of x. So it's g of x. All right, let's look at example 1. All right. Example 1 is asking us, given that f of x is equal to 2x minus 5 and g of x equals x squared minus 3x plus 8. Hey, let's look for these. First one says, let's find f of g of x. And then part 2 of that one is find g of f of x. So this one is f of g of x. And this one is g of f of x. So what this means is the g function, this function here, goes in place inside the f function. Anywhere seen x, we put a g of x. So this equation goes in place of x. So it becomes 2. Now in place of x, we put the g function. X squared minus 3x plus 8. That's x minus 5. Now we got to simplify. We have to get rid of the parentheses, so we distribute. 2 times x squared is 2x squared. Positive times negative is negative. 2 times 3 is 6x. Positive times positive is positive. 2 times 8 is 16 minus 5. Combine like terms. Whenever you get rid of parentheses, first thing you always combine like terms. We have 2x squared minus 6x. And these are opposite signs. 16 is bigger, so it's positive. 16 minus 5 is 11. So that's our answer. Okay, what this one says is inside the g function, anywhere we see an x, put the f of x function. So we take this function, anywhere we see an x, we put this function. So here we have x squared. So inside of x, we put 2x minus 5. So it's 2x minus 5 squared minus 3, 2x minus 5 plus 8. Because remember, what this thing tells us here is in place of x, we put f of x. So we have f of x squared minus 3 f of x plus 8. So anywhere we're seeing f of x, we put that equation. This first one is a squared term, so that means 2x minus 5 times 2x minus 5 minus 3 2x minus 5 plus 8. So we have to multiply these two together. 2x times 2x is 4x squared. Positive times negative is negative. 2 times 5 is 10x. Negative times positive is negative. 5 times 2 is 10x. Negative times negative is a positive. 5 times 5 is 25. That's all for that one. Now for this one. Negative times positive is negative. 3 times 2 is 6x. Negative negative is a positive. 3 times 5 is 15 plus 8. We'll get rid of parentheses, so combine like terms. Okay, let's start with the highest. So we have 4x squared. We have negative 10, negative 10, negative 6. They're all negatives. 10 plus 10 is 20, plus 6 is 26x. So that these are all taken care of. Then we have all of these are positive. 25 plus 15 is 40, plus 8 is 48. And there's the answer. All right, so that's A. B is asking us to do the same functions, f of g, but this time, instead of x, we now define x with a 7. And the second one is g of f of 7. So what this one means is the f function of g of 7. So the f of g of 7. This one is the g function of f of 7. So we'll follow the order of operations. Work with first find g of 7. Remember, f of x was 2x minus 5, and g of x is x squared minus 3x plus 8. So g of 7, go to the function g. Anywhere you see an x, put a 7. So it's 7 squared, 3 times 7 plus 8. 7 squared is 49. Negative times positive is negative. 3 times 7 is 21 plus 8. (49 minus 21 is 28. plus 8 makes it 36. So G of 7 is 36. That's the inside there. So what we have now is F of 36. Because we have this, and now we define what G of 7 is. So now we got to find what F of 36 is. F is 2x. So anywhere see an x, put a 36. Thirty-six times 2 is 72. Minus 5 equals 67. Right, so let's look at the next one. Here we have G of F of 7. So the first thing we have to do is find the inside. Find F of 7. F is 2x minus 5. Anywhere see an x, put a 7. Two times 7 is 14. Minus 5 is 9. So F of 7 is 9. Now, what this means is anywhere in our function, anywhere we see in our function that we see an x, we put F of 7. So what we're going to have here is F of 7 squared minus 3 times F of 7 plus 8. So we have to first find F of 7, which we did. Now we combine those. We put the number 9 inside the G function, because F of 7 is 9. So then we have G of 9 equals 9 squared minus 3 times 9 plus 8. 9 squared is 81. Negative times positive is negative. 9 times 3 is 27 plus 8. 81 plus 8 is 89 minus 27. 9 minus 7 is 2. 8 minus 2 is 6. So that gives us 62 as an answer. C is looking for GOG of 1. So what that means is G of 1. Remember, G of x is x squared minus 3x plus 8. So the first thing we have to do is find G of 1. So inside here, anywhere we see an x, we put a 1. So it's 1 squared, 3 times 1 plus 8. 1 squared is 1. Negative times positive is negative. 3 times 1 is 3. 1 plus 8 is 9. Minus 3 is 6. So G of 1 is 6. So now we combine these two. We know inside here, G of 1 is 6. So we have G of 6. So anywhere see an x inside our equation, we put a 6. 6 squared minus 3 times 6 plus 8. 6 squared is 36. Negative times positive is negative. 3 times 6 is 18 plus 8. So we have 36. Negative 18 plus 8. 18 is bigger, so it's negative. 18 minus 8 is 10. 36 minus 10 is 26. That's our answer for that question. Right? Let's look at D. D is asking for f of x. Remember, f of x, the function was 2x minus 5. So what this one's asking is f of x. So it's f of x. What is f of x? F of x is this equation. So inside there, we put what f of x is. So now, in place of x in our function, so we have function f, anything inside the parentheses is the x. So anywhere I see an x, I put this equation. So it's 2 times 2x minus 5. So it's 2x minus 5 minus 5. Get rid of the parentheses. 2 times 2 is 4x. Positive times negative is negative. 2 times 5 is 10 minus 5. Combine like terms. They're both negative. 10 plus 5 is 15. And there's your answer. Right. Let's look at example 2. Example 2 says, given that f of x equals the square root of x and g of x equals x minus 3, find the following. So A is asking find f of g, which means f of g of x. Then it's also asking find g of f, which is the g of f of x. What this one says is in my f function, anywhere I see an x, I put the g of x. So I take this equation, that's my g, and inside the f, anywhere I see an x, I put that in its place. So there's right in place of x, I put x minus 3. So that is what goes in place of the x in that. This one, inside the g function, anywhere I see an x, I put the f of x function. So I take this equation, anywhere I see an x, I put that. So it's square root of x minus 3. So there's now part B is asking find the domains. So the domain of this one, remember the transformation. The original function is a square root. it can't be negative, so it goes like that. Inside here is a horizontal shift. We shift it to the right 3 spaces. So our domain now for that first equation is 3 to infinity. Or since we're dealing with the x-axis, say x is greater than or equal to 3. Reason it's bracket, because we start there. We can use that number and all the other x's after that. The domain of the second equation, square root of x minus, this just means it's a vertical shift. The graph is still a square root, and it goes down 3. So the domain is still from 0 to infinity, because that's this one. That's the only x we have. So what's the domain of that function? So it's 0 to infinity, and you can include 0. So you can say that x is greater than or equal to 0. All right, let's look at example 3. Example 3 says, given that f of x is equal to 1 over x minus 2, and g of x is 5 over x, find f of g and g of f. Remember, this means f of g of x. And this means g of f of x. So what this first one says, in the f function, this first function, anywhere I see an x, put the g of x function. So here I take this equation, anywhere I see an x, I put it there. So I have 1 over 5 over x, that's where x is, minus 2. But we're not done because it's a fraction and a bunch of other stuff. So we have to combine like terms. We have to have a common denominator. So we have a 1 here. This one is 5 over x. This one's 2 over 1. So you need the common denominator, which is x. So this one needs an x over x. Now we have a common denominator on the bottom. It's x. So it's 5 minus 2x. This is actually a fraction over fraction because the top is made up of 1 over 1. And the rule here is take the top fraction, leave it alone, which is just 1, and flip the bottom. So this one is just 1, so there's nothing there. And flip the bottom, we have this. The domain of this one is what makes the bottom equal 0. So we take the bottom, set it equal to 0, and see. So we have 5 equals 2x, divide by 2. So x equals 5 over 2. So when x equals 5 over 2, we get 0 on the bottom. So we can't use that. So if you think about it, the only number we cannot use is 5 over 2. We can use everything else. So our domain goes from negative infinity to 5/2, and I can't use it, unioned with 5/2 to infinity. Now, what's happening here, it comes from this rule. If you have a fraction over a fraction, so a fraction divided by a fraction, take the top fraction, leave it alone, and then multiply by the reciprocal, the flip of the bottom. That's what we did in ours. We had 1 over 5 minus 2x over x. So it's a fraction over a fraction. So take the top fraction, leave it alone, multiply it by the flip of the bottom. 1 times x is x, and 1 times that is that. So that's how we got our equation. And because it's a fraction, the only numbers we cannot use are what makes the 0 on the bottom. That's what we did this part here to find the domain. We cannot use this number. All right, let's look at the second one. G of f. What this one says is I take this equation, anywhere I see an x, I put it inside there. So I have 5 divided by x is going to be 1 over x minus 2. So it's a fraction over a fraction, which is 5/1, times the flip of the bottom, which is x minus 2 over 1. The top is 5 times x minus 2. 1 times 1 is 1. So it's just nothing on the bottom. So we can distribute the top, we get 5x minus 10. Because it's not a fraction, this is a linear equation, our domain is from negative infinity to positive infinity. All right, let's go backwards now. Well, we'll look at it as going backwards. Decomposing a function as a composition. We're going to look at example 4. Example 4 says, if h of x is equal to 2x minus 3 to the power 5, find f of x and g of x such that h of x is f of g of x. Because the way it said it, it's important. Because what this is saying is h of x has to be like this. So g of x has to be the number that's inside the bigger function. So we have g of x is the inside function and f of x is the outside function. Well, the inside function we can see is this one right here. It's inside the equation. So it's 2x minus 3. And the outer function is x to the fifth. Because in this, f of g of x, we take f of g of x. So this goes inside here, we get that. Example 5. If h of x is equal to 1 over x plus 3 cubed, find f of x and g of x such that h of x is fog, which means f of g of x. So we're looking for g of x will be the inside function. So which function is inside another function? Well, we see this one's inside the parentheses, so that's the inside one. So if we make that into x, what's our other equation? 1 over x cubed. Okay, it's not the only answer we can have because we can look at other type of questions. We could say that g of x can be the whole bottom number. It could be x plus 3 cubed. And the function f of x could be then 1 over x. So yeah, as long as it fits some form of library of functions, it'll be a right answer. Let's look at a couple more made up of examples. Let's say h of x equals the cube root of 5x squared plus 2 minus 5. We want f of g of x. So that means f of g of x. So we want g of x to be the inside one, and f of x will be the outside one. So here's the function is a cube root. So whatever's inside of it, that's my g of x. Because it's inside the bigger one. So now, if this is my x, what does the f function look like? Cube root of x minus 5. And another one, 1 over 2x squared plus 5x squared plus 4. This time, I'm going to look for g of f of x, which means I have g of f of x, which means f is my interior function and g is my outer function. So is there any function inside parentheses or special operations? Yeah, right here. So that's 2x squared plus 5x. If that disappears, if that just becomes an x, what do we have left? 1 over x squared plus 4. And that's what the bigger one is. So those are your examples for composition and decompositions. All right, good luck, everybody.